Hello, welcome to Chapter 6, questions 16 to 21. Let's go ahead and get started on 16. The price of homes in thousands of dollars is associated with the number of square feet in a home. Home prices in Smallville can be modeled with the equation P equals 150 plus 0.041 times A, where P is the price of the home in thousands of dollars and A is the area of the house in square feet. Home prices in Fancyville can be modeled with the equation P equals 250 plus 0.198 times A. Noah saw a real estate advertisement for a 2,800 square foot home that was selling for $280,000. Which city should she predict that the home is in? So given the two equations, first one is in Smallville, and that equation is P equals 150 plus 0.041 times A. We can plug in the square footage of the home and see what the price is and see if it matches up to the price of $280,000. And then we can do the same thing with the other town, Fancyville. And that equation for that town is P equals 250 plus 0.198A. And all we're going to do is plug in the area for each of these, 2,800. And then for this one over here, same thing. Plug these into the calculator and see what the price should be. So for Smallville, I got a value of 264.8. Now remember, that is in thousands of dollars. So the actual prediction or price we would have would be $264,800 for the 2,800 square foot house. And then on this one, when we plug this one in, we get 804.4, and once again in thousands of dollars, that's $804,400 for a 28 square foot house. So which city should she predict that the home is in? Well, the selling price was $280,000, so which number is closer? Fancyville is pretty fancy. We got an $800,000 home. Smallville is more around the $280,000 mark, so the prediction would be that she would predict the home would be in Smallville. And so make sure you answer the question. Question 17. For this sequence, 5, 25, 125, and 625, we're going to do three things. We're going to describe what kind of sequence it is, find the fifth term, and then write an explicit equation for the general term A sub n. So the first one, what kind of sequence is it? Well, what's happening here? To get from 5 to 25, we are multiplying by 5, and then 25 to 125, once again multiplying by 5. So we can see that this is a geometric sequence. On part B, find the fifth term. Well, we already have the first four, so we could write an equation to find the fifth term, but since we're only looking for the next term, we can go ahead and take 625 and times it by 5 to get the fifth term. And therefore the fifth term would be 3,125. All right, and then part C, we're trying to write the equation. So if we wanted to find a larger term than the fifth, we could plug it in. So the explicit equation, A sub n, so for any term number n, A sub n is equal to, what's the initial term? Now remember, the first term is 5, the second term is 25, and so on. We want to go back and find term 0. So if we're going to multiply to get the next term, we'll divide to work our way backwards to get the first term. So 5 divided by 5 is 1. So our first term is 1. So A sub 0, I shouldn't say our first term, our 0 term is 1. And so now we have the initial, so that's the starting one, which is at term 0, times our multiplier of 5 raised to the nth power, because that's what's happening over and over again. So when you multiply 1 times something, you're just left with 5 to the nth power. I'd take either one though, but you do have your initial or your starting value at term 0, 1 times the multiplier, the generator, 5 raised to the nth power. Question 18, write an explicit equation for the sequence based on the graph below. So now we looked at a sequence based on the pattern. Now we're going to look at the graph to identify the equation. So what we want to look at is where each of these points are located. So the first one is at 1, 4, 2, 10, and 3, 16. So the x value is n, which is the term number. So this is the term that we're looking for. And then the t of n, which is your y value, that's the term value. Okay, so we're going from term 1, 2 to 3, and then we're getting, and I'll write it out so you can see, 4, 10, and 16. So what is happening to get to the next term? You're adding 6 and adding 6. So we can see that our generator is plus 6, and then if we have to work backwards, we need to find term 0, because right now this is term 1, 2, and 3. So to get term 0, we work backwards, and we're going to subtract 6 to get that one, and if we do that, we would be at negative 2. So now we have all the information that we need. We have term 0 is negative 2. I'm going to use the t notation. So t of 0 is equal to negative 2, and we also know that we are adding 6. So that allows us to write the explicit equation. T of n is equal to 6, which is the generator, so 6 times n, and then minus 2 would be that term 0 that we're looking at. So that's that form. If you chose to use the alternative form, a of n, could look like this. A sub n is equal to 6 n minus 2. So same thing, but a sub n instead of t of n. Either one is fine. But it has to be an explicit equation. Question 19. Lisa is weighing combinations of children's blocks. 4 blue blocks and 5 red blocks weigh 32 ounces. 1 blue block and 8 red blocks weigh 35 ounces. What is the combined weight of 1 red and 1 blue block? So when you're reading through this, you might have a question as to how to kind of get it started, but the question at the end is asking two things. What is the combined weight of 1 red block and 1 blue block? So we want to combine the weights, but we don't know what either one of them are. So why don't we create let statements that represent each of these? So we can let R equal the weight of the red block, and then we can let B equal the weight of the blue block. So we have 2 unknowns, and we need to write 2 equations then. So let's kind of read back through this. Lisa's weighing combinations of children's blocks. 4 blue blocks and 5 red blocks weigh a total of 32 ounces. So let's take that and write an equation. 4 blue blocks plus 5 red blocks weigh a total of 32 ounces. Now let's take the next line. 1 blue and 8 red weigh 35 ounces. So 1 blue plus 8 red weighs 35 ounces. So now we have 2 equations and 2 unknowns, and we can go ahead and solve. Either elimination or substitution would be fine. I'm going to go ahead and use elimination. It's kind of set up for that, where my b variable and my r variable being added together with my constants on the right. So I'm going to multiply the second equation by negative 4 so I can eliminate my b variable. So I'm going to rewrite this one right here. So this would be negative 4b minus 32r is equal to negative 140 for my constant. Alright, And then I'm just going to take my first equation and rewrite it. I don't need to change anything. So this would be 4b plus 5r is equal to 32. And we'll add these two up. So the b variables eliminate. Then you're left with negative 32r plus 5r, which would be negative 27r, is equal to negative 108. Divide both sides by negative 27, and r would be equal to 4. And so that represents not 4 red blocks, that is the weight of 1 red block. So be careful there, that's the weight. Now we want to find the blue one. So we'll use the equation 1b plus 8r is equal to 35. So 1b plus 8 times 4 is equal to 35. So b plus 32 is equal to 35. Subtract 32 from both sides, and you have b is equal to 3. And once again, this is the weight of 1 blue block. Alright. Now the question doesn't ask how much a red block is and how much a blue block weighs. It asks what is the combined weight of each of them. So one red block is 4 ounces. And then one blue block is 3 ounces. So combined, that will give you 7 ounces. Question 20. Rewrite each equation by following, let's try that again. Rewrite each equation by solving for the indicated variable. So on part A, you're solving for W. Everything is multiplication though. You have length times width times height, or L times W times H. You're solving for W. So to undo multiplication, we're going to divide, and we can divide by both of them at the same time. So therefore, W is equal to V divided by L times H. On B, you have a linear equation, and you're solving this linear equation for X. So the first thing you need to do is subtract the 3 to the other side. Y minus 3 is equal to X divided by 2. And we can undo division by multiplying by 2. So that will leave X on the right-hand side, but because there's a quantity, more than one term, on the left you have to distribute the 2 to the Y and to the 3. So that would be 2Y minus 6. So X is equal to 2Y minus 6. If you left it as X equals 2 times Y minus 3, that would be acceptable also. C. E divided by R is equal to I. E divided by R is equal to I. We're going to solve for R. Now R is in the denominator, so we need to undo that. So E divided by R, we're going to multiply by R to both sides. That way the R cancels. Now it doesn't solve for R, but it at least gets it out of the denominator. Now to solve for R, we can divide both sides by I. So R is equal to E divided by I. And then the last one, D. 2x plus 1 divided by y is equal to 3. This one we're going to solve for the y variable. So before we can once again mess with what is here in terms of y, we need to somehow take this 2x and get it out of the left side of the equation. So we're going to do that by subtracting 2x to both sides. So now we're left with 1 divided by y is equal to negative 2x plus 3, or you could have done 3 minus 2x is fine. And same thing as a little bit ago, to get rid of the denominator, we're going to multiply both sides by y. But because the right-hand side of the equation has 2 terms, the whole thing needs to be multiplied by y. So we have 1 is equal to, now this time I'm not going to distribute, and you'll see why, negative 2x plus 3 times y, because we're trying to solve for the y variable. And if I would have distributed, I would have created 2 more y values or variables, and I didn't want that. So now since it's y times that whole thing, to get rid of all of that, we can divide by that quantity, negative 2x plus 3. So y is equal to 1 divided by negative 2x plus 3. All right, and there you go. And that was a little tricky there, especially with the y, and making sure you don't distribute so that you can divide by all of that to get it to the other side. Question 21, use any method to find the point of intersection of the lines, x equals 3 and y equals negative 2. Now, we've done this before, and we've done substitution and elimination, and it's worked fine. Now we're looking at this, and it's like, well, what are we substituting, and what are we eliminating, and everything else? Because x equals 3 is a vertical line. So at x equals 3, here's your vertical line at x equals 3. So instead of solving this algebraically, I want to show you this graphically. So that's this one. All right, and then the other one, y equals negative 2, is a horizontal line at negative 2. So we're going to have this line, y equals negative 2. We are looking for the intersection of the 2 lines. So you can see right here is where they intersect. What would that ordered pair be? Well, we went over 1, 2, 3. That's x equals 3. And we went up 1, 2. Or wait, I'm sorry, I went the wrong way on that one. Let me go back. Got my lines confused. This is the intersection point right here. Sorry about that. So there's the intersection point. So we went over 3 units. That was x equals 3, and then we went down 2 units, and that was y equals negative 2. So because it's a horizontal and vertical line, your intersection point is going to be exactly what those 2 values are, because that's where they're the same all the way across. So x is equal to 3, and y is equal to negative 2 is the point of intersection.